this. Thanks for joining. Today we have day number 10. We are going to learn about the application aware routing policy, which has a lot of buzz. Buzz means that, you know, app route policy. So when SD-WAN got introduced, so everyone was telling that, oh my God, now we can go and create policy based on applications. Now everything is if you see this application-centric architecture of data center, that's Cisco ACI, or software-defined data centers, that's VMware, NSX-T, those providers, so either NSX-T provider or ACI provider, they are telling that now the infrastructure is application-based. That means that company will not think much about the network infra, but they will think about the applications, and then their network will work as per the application requirement. That's the core. Earlier, it was like routers, switches, servers, everything connected with the cables, wire, and all, right? And then on top of that, we are running the application. So network, people are thinking about the network and then developing the applications. Now, with a new phrase that we have application-centric infra, that application in the core, and then according to that, we are building the infra. Right. So that's why lot of buzz about this application aware routing policy, that you can create policy based on applications, for example, HTTP traffic, or for example, if you have audio video traffic and audio video traffic, they are if they are latency sensitive, then if this link is gone, then down, then automatically it will shift to that link and that link and that link. But what is the reality? Reality is this, that okay, we are shifting towards the software, but still you need some sort of hardware. The only good thing happen is this, that the unification of devices happens. Like earlier you have different firewall, different IPS, different routers. Now with help of containers, some virtualization technology, with some enhancement in hardware like RAM, CPU, etc., etc., in a single box you can do all those things. Same is the case with the data center. Single box you have storage, single box you have uh, some sort of computing. So computing is there, storage is there, right? And little bit of networking is there, and even the security is there. So single box, you can do multiple things, but there are pros and cons. We can discuss about those things as well, that there are advantages and there are disadvantages. By the end of day, you will see all the companies, they are building their own data center, right? So nowadays, everyone try to become the service provider. So if they have their own data centers, right, then you can build your own applications. Then you can sell those applications. That is the trend. So all big guns that we have globally, like in India, we have Reliance, we have some Adani Group. They are building their own data centers. Although Reliance, they have their data center in different locations, but now I will go and put this recording in YouTube. So they will ask me the 100 things if they watch this recording. But the Reliance data center is not up to mark, you know. It's like not good a standard data center. If you compare the data centers that we have, maybe for Facebook, for Google, you know, those big companies. So what is the differentiator here? The differentiation in between the very good giant companies and their profit is their data center. Somehow they come to know that if we go and build the infra, later on, obviously we can go and develop the applications on top of infra, right? Like Google, they have their big application. Amazon, they have their big applications, and not the business critical applications like Facebook, you know, some social engineering type of softwares like WhatsApp, Facebook, and LinkedIn, and um, there are so many different, applications and social media platforms are there. But behind the scene, what is the core? What is the core of cloud? Data center. Core of services or businesses, data center. So people know that, okay, if we have data center, then we can earn like anything. And then they are building their own data centers. You know, now in data center, what's the core? Applications. So how we can handle the applications? If we have data center and suppose if we have 2000 branches, right? You will not go and plant data center everywhere. Somewhere you have your physical resources, somewhere you can go and host application to the cloud. But there are endpoints in terms of designing, we can think small branches. They can be your endpoints, like branches terminating here and there. And those branches, maybe a small branch is there, but revenue is very high for that particular branch. I can give you an example related to very small branch and high revenue. All these liquor companies, right? All these liquor companies, although they have storage, like local storage and global storage, they have very small IT blueprint, like to the to, to the uh, to the places from where they are selling their liquors and wines and blah blah all those things, right? So point here is this, that there may be a very small branch, but the revenue may be very high. It may be, right? But for those branches also, you don't want to go to the data center and use the resources. So for those branches also, although they are using only two applications, one is how to put that beer or liquor sale invoice within the main data, maybe Tally, they are using Tally or any type of data services, database, etc. So what do they have to do? They have to enter how many bottles, how many carrot, how many trucks, came to the site, and then how many truck, how many bottles, carrots going outside of the site. So entry, and then the ledger is there about the money. So maybe they are handling only three applications, three client application, not the server application. So they have some client patches that they can put one entry, press enter, and then it will go to the data center. Maybe data center is in some other location like Mumbai, Bangalore, anywhere, like central locations. So how this will flow securely? That's the whole idea about app route policy. Later on in app route policy, if you go and add the firewall in this app route policy, then it will become application aware firewalling policy, right? Because firewall, they can sense the application metadata. It will not go and check the entire application, but a few of the signature or a few of the footprint, you can say, of that particular application. For example, HTTPS application. So what is the nature of HTTPS application? Before sending the actual data, they will build the tunnel. They will go and do some certification process, build the tunnel between client and server, and then actual data will transfer. So they will go and check that, oh, this application is sending, receiving a certificate. That means that it is HTTPS. Then if this is some secure FTP, or this is some secure cell, etc., etc. So they can sense the metadata, they can sense the transaction of that particular protocol, and according to that, they can understand, the firewall can understand that this is what type of application, and for this application, what type of rules I have within my firewall. Right. So it's not only that we have Cisco SD-WAN, that FortiGate, they have their SD-WAN, the Palos, maybe they have their SD-WAN. Yeah, they have their SD-WAN. And there are some other uh, firewall companies, they have their own SD-WAN. So when they have to go and sell their product to their customer, what they will tell, hey, I have one SD-WAN solution where my focus is security. See, Cisco is not providing this security. See, Cisco, when they are sending these many applications, their devices are getting heated, busted, memory is always 90% high, CPUs, this, all those things. And then they will tell, oh, we are using this application for this particular we are using this security rule for this particular application, and this is my patented application. This is the application that only my hardware can support. So that is your what, vendor locked security. That's the way that companies, they are earning money, selling their services, earning money. But anyways, behind the scene, they are doing a lot of research, lot of client feedback. They have their business units, they have their research units, right? So according to that, they are charging the money. But this is the whole cycle, that building the data center for all the entrepreneurs, that big companies, they are building their data centers. Then the network providing companies, they are also building their data center somewhere. They have their SOC team somewhere. They have their security team somewhere. But their mode of earning money from the market is different, right? So either it's a network or security service providers, or it's a business service provider. What is the core again? Core is the application. They are also building applications, selling services, the services and application. So now we have the service and application. Now these services that we have, this is slowly removed by application. That's the AI applications and all. So two things are there, application and services. Services are slowly it is removed, or maybe you can see that a lot of firing is happening in company because these services are slowly replaced by the automation and AI. So earlier automation peak was there, but most of the companies, they are not using automation because of some reason. And most of the companies, they are not using AI as well, but still you can see the firing is happening in the company. Why? Because they are not removing 100 out of 100 employees, but they are removing 80 out of 100, or maybe 50 out of 50, because now 50 employees can learn those automation AI and can do 100 employees job, right? But anyways, that's the way things are moving. Long story short, we have to learn about app route policy here. So I'll go and explain you that. It's actually super easy. Let me open my blackboard, not whiteboard. So in this blackboard, what you need to do here, list the application, create the application list, right? And then go and define the SLA, loss, latency, jitter, LLJ. And then as per the SLA, if you go map the application with SLA, then it can go and take action. So either go via MPLS or internet. That's it. That's your application aware routing policy. Very easy, straightforward. With example, how we can understand this. So what I will do here, I'll create two application list. I'll go and create one application list name HTTPS, or maybe let me do one thing like corporate. Application name is corp traffic. In this, what I will do, I'll go and add the web-based traffic and web email or email traffic, web email. I'll go and put these two applications. Then I'll go and add corp traffic and web. I'll add here corp traffic web. Corp, corp traffic and audio and video. In this, I will go and pass SIP and RTP. I'll try to search these two applications and I will put here. Now I'll go and create one SLA. SLA for web. So web SLA, where I'll go and put some loss latency jitter parameter. I'll show you that. Then I'll go and put one audio video SLA. There also I'll go and put some loss latency jitter parameters, right? And then finally I have two circuit. I have MPLS and I have internet. So for this particular traffic, actually for both what I will do, I'll prefer MPLS and I will fall back to internet. Right, I will go to MPLS. MPLS will be my primary circuit, and if loss latency jitter will be more than 100, so I'll give one parameter. If it is more than 100, then fall back the circuit towards internet. Okay, let's do this. So now let's go to our SD-WAN. And here you can go to the configuration and the policies. You know that this will be falling under centralized policy, data policy, right? So I can go and create the application list. What is my application list? Corp, traffic, web. I go and try to search web. Maybe it is under application family. So let me check this. Web. I'll go and add these two. Then I'll go and add new application. Corp. Use like this. Corp, traffic, and audio and video. Now let me try check. Family is there actually, audio, video, which has some SIP and RTP and all this. If I go and search audio, video, within this automatically I'll get all those RTP and SIP and all those traffic category. So I have these two traffic, then color, community, data, policers, prefix, sites. Yes, I need sites. I will go and apply this to all the branches and all the data centers. So DC is already there, you can see, and all branches is already. So all DC and all branches are already there. So this is there. Then app prop class, SLA class. I'll go to this SLA class. I'll go and create one SLA. See, web based SLA. Loss is maybe more than 2%. Latency is 100 millisecond. Jitter is 100. You can give any number here. That's fine. Add. Then I'll create one more. Say audio, video based SLA. Loss maybe 4%, maybe 200, maybe 200. Or you can leave it as well, like, only if loss is more than 4%, then it will take decision. So now we have list of applications. Now we have list of site. Now we have list of SLA, like, conditions. Now we'll go to the application aware routing policy section. Create new. Corp AR. Then I can go to sequence rule. See application. I have application called Corp Web, Corp Traffic Web. Now for this application, what I want to do, so matching the application, and then I can go and take the action, SLA. SLA will be a web-based SLA. Do I have any preferred color here? So preferred, I will prefer this to MPLS. And load balance to MPLS and this. And if you want, you can drop it. If you go and use this option, strict drop, that means this traffic will go and try to check MPLS is available. If it is not available, it will drop it. Right. But what I want here, that I want the backup as well. So I will go and add the backup as internet. So my primary is obviously the MPLS, but my backup is internet. I'm load balancing anyways. Save this. Now I can do one thing here. I'll copy this and edit because I have one more application as well. That is the Corp audio video. This one. So for this also, I want to prefer this but I have different SLA, so let me go and change the SLA first. For this, I have audio video SLA where uh, what was the loss is 4%, more than 4%, then it will take action. Prefer MPLS, backup is internet. I can save this. Now, this application aware routing policy is the only positive policy that you don't need to go and use the default action, because by default it will allow everything with some tunnel, default tunnel. So now we'll go and apply this policy. So in the final phase, we want to apply this. So you'll come to this app route policy, and I want to apply this to DC, all DC and all branches. And VPN, actually I want to apply to VPN 10. Even you can go apply to VPN 20 as there's no problem, I think. Click add. Now if you click preview, you will see the policy. So I have one web audio video SLA where loss is 4%. I have web SLA where loss latency jitter, I have fixed these parameters. Then for VPN 10, for all the traffic, for the application web based traffic, the SLA, the preferred color is MPLS, right? But what is the backup color? Backup is internet. Likewise for VPN 20 as well. So here you can see that this is VPN 10, sequence 1, okay. And this is VPN, same VPN, sequence 11 for audio video. So for audio video also same. So point here is this, for VPN 10 and VPN 20, we have different applications that we are preferring MPLS and backup is internet. And then finally, we are applying this towards the data center, towards all the branches, right? Now here you can see that within audio video, we have this audio video family, but within that web, we have webmail, the audio video, audio video is also there. Web is there, peer-to-peer database, application, like this is application family. Although we have this option that we can go and choose the certain applications as well. So I want to add Facebook, YouTube, Twitter, those things. Why not? Let's see this. So let's go to that centralized policy, and the traffic policy is your data policy, right? Corp AR, click edit. Okay, I'll add one more policy here, add sequence application. I haven't created it, I'll select it. I'll try to search new application list. From here itself, I'm doing the search, not from the list. Click this. Now I want the application. Let me give the name. Say, let me give the name. Corp social media traffic application. Let me search Twitter. Sorry, Twitter. This is X now. Let me try to search more applications like Facebook. In Facebook also you can see multiple Facebook, audio, video, blah, blah. And then, oops, YouTube, Yuku. Anyways, save. Okay, so let's check that. Corp social media. And then what action you want to take? I want to take action as preferred as if I have any best effort, I haven't created that, but it was there. And the preferred color is internet. And then if go via internet, drop it. I don't want to load balance or anywhere send to, MPLS and all. Say this. Okay. Now, if we go back to the centralized policy, Corp AR, we click preview. So you will see that we have added one more in sequence 21, social media, where what is the action? Best effort. SLA is best effort in action, and it is strict. You can see the keyword is strict. That means that this social media traffic, right? It is using best effort, right? And the SLA is best effort, and it is only preferring the internet circuit. If internet circuit is down, these application will be down. They will not load balance to MPLS or anything. Make sense, right? Then you can see the list of the uh, social media. Now you can go and increase this amount, length of all the social media policies and all. Anyways, let's save this and let's activate. So once you activate, what will happen? I told you earlier that these policies that we have, they are the data policy, right? A data policy is something that will go to your VS Smart, but all the edge devices, whatever devices that you are pushing this policy, they will also download this policy. So for example, if I go to branch 2, VH1, and if I to show policy from VS Smart, you'll see this, it will download that policy, right? Now, if you go and try to check show, see app route option is there. App route states. Then you can see actually with the states, you can see the loss latency jitter parameter. At the moment, the zero loss, zero latency, everything is clean, right? So if I go and check the traffic pattern here, what is this IP? Let me check that. So interface description. As 3.106. Okay. Let me go here and SSH. Okay, show uh okay app DPI flows VPN 10. I just wanted to show you that within my VPN 10, right? What type of applications I have. So within my VPN 10, I have this RTP. What is the family? Audio video. I have this HTTP. What's the family? Web, mail, right? Anyways, I'm going to check with this audio video because this is going from the branch 4 towards the data center. This is the destination IP 10.1 that is assumed to be there in data center. Actually, this is data center IP and 10.4 is my branch IP. 10.4 is branch and 10.1 is the data center. So this traffic, I will go and track the RTP. Application is RTP. We will go and check that via which particular tunnel. It is going via MPLS or is it going via internet? That we'll try to examine first. Oh, we shall clear. Okay. So what we can do, show tunnel and stats. It's not like that. How we can go and verify this? That it is going via which particular, I think tunnel is show tunnel. Do we have source destination IP? Oh, source IP. So 10.4.0.1 is the system IP. Destination IP. Suppose 10.1.0.1 is the data center IP. It's asking about ports as well. Anyways, clear. Let me exit. First, we'll check the tunnel path. What's the command that we can go and check the tunnel? The application. Or do we have anything related to tunnel? But should just have the show. Tunnel is there. Show app. Let me check that.
I think that was show apps Cflow something. The command, yes, Cflow.
Seafloat is a different thing, right? With seafloat, it will tell you the flow of the traffic. It will not tell you about that tunnel paths and all, right? I just wanted to check that I have my RTP traffic. The RTP traffic will go via which particular tunnel. So then what we will do, the target here is this, that then we'll go and increase the latency over one path to the other path. Once we'll go and increase the latency, after that we'll see that it should change the destination. It should go via some other path,
Different, yeah, yeah.
different path. So in that case, we'll go and change the uh, you know the loss latency jitter. The simulation is there in our lab. You can go and simulate the loss latency and this jitter. So this tunnel path is there. So you can see this show policy tunnel path. Suppose VPN 10 interface KK source IP 10 dot my source IP is 10.40.1 and then the destination will be 10.1 towards data center and protocol is RTP protocol is 17, right? This TCP and UDP. TCP protocol number is 6 and UDP protocol number is 17, right? So that's why 17 question mark application. Oops. RTP. Let me show you on top. So what command I executed is this command. So policy tunnel path, you can see that it is going via the RTP traffic is going via MPLS. Let's see here. This RTP traffic is going via MPLS, right? So what we will do now that we will go, first of all, let's verify, show app route, stats, enter. Then it will show you all the loss latency jitter. Everything is 000 actually. Just focus on this portion here. All these are 000. Loss latency jitter. Everything is 000. So what we will do here that we'll go and increase this. So now if I go to my dashboard here, if you open new tab, see WAN compartment is there, If you go here and click branch 2, which transport you want to inject that, so MPLS. Now if you come here and if I press up arrow, it will take some time, but you will see that for one of the tunnel, loss latency jitter will increase. I can see latency is increasing here now. This is the tunnel. It is going from where to where. If you see this tunnel, app router stats, this is the IP from this tunnel to this tunnel. This is the remote is data center. So here you can see that is increasing. We'll give some more time. Now you can see the latency has gone increased like anything here and here also. But this is in branch 3. I'm mainly concerned with this particular data center, source to destination. Source will be my 10401 and destination will be the data center. I can see that it has changed this destination. Now it is going towards the internet, this traffic. Earlier it was going via the MPLS. Let's do one more time. Make sure it is not changing the path load balancing. This is internet, right? Let's go back here and remove latency. Come back here. It will take some time because you know that latency will also go slowly, not at the moment we remove and it will go out. I'll just say it will take some time. Meanwhile, you can go and check the stats. So it will clear. You can see it is clearing now. Now if you go and check, you see now it will fall back to internet after some time. Let me go on top MPLS. That's it. Your app aware routing policy is working like this. That you have the list of applications, you have the SLA. If it will match, it will react like this. It will not match, then it will react like this. Okay, you have any query, please feel free to ask.